Okay, so the continue of the last video is with some mistake that video has been stuck. So let us we continue that problem. So as we got the total in this equation we find that alum requires 486 parts of natural alkalinity as a CaCO3. Okay, so for every 666 parts of alum and also 162 parts of natural alkalinity is required to 100 parts of alkalinity. As we know, the molecular weight of the calcium carbonate as alkalinity is 100 and for the bicarbonate is 162 and quicklime, that is calcium oxide, is 56. By concluding, by seeing these equation, these molecular weights, we can say for every 666 parts of alum and also 162 parts of natural alkalinity is equivalent to 100 parts of alkalinity, right? 100 parts of alkalinity. So for that reason, hence we required required alkalinity as CaCO3 for water containing alum of 20 mg per liter. That for that we can find out alum and CaCO3. So alum is 1 mole, that is 666, and calcium carbonate is 3 moles. As we know the equation, 3 moles of calcium carbonate, right? So here 3 moles of calcium carbonate means 3 into 100. That is the molecular weight of the calcium carbonate is 100. So as we having the that is the treatment plant requires how much amount of alum is 20 mg per liter, 20 mg per liter. So by equating these two, we can say here 300 into 20 divided by 666, we will get 9 mg per liter. So this is what the alum required. So natural alkalinity available as, therefore natural alkalinity available as CaCO3 equals 4 mg per liter. So already this will given in the question, that is 4 mg per liter is available in the water sample. So therefore additional alkalinity required to be added in the form of lime equals 9 is the required alum, that is required alkalinity for the water sample, and already 4 mg per liter is present in the natural water. So we requires the additional alkalinity as 9 minus 4, you will get 5 mg per liter. So this much of alkalinity we are going to add now. This much of amount we are going to add in the water sample. For that reason, since lime which is available before, that is in the form of lime, we are going to add the alkalinity to the water sample. So lime requires is 5 mg per liter. Since 100 parts of calcium carbonate produces 56 parts of quicklime, that is calcium hydroxide. Therefore the quantity of calcium oxide required is equal to 5 into 56 divided by 100. So this 100 parts of alkalinity, that is molecular weight of the calcium carbonate, is 100, and this produces the 56 parts of calcium oxide. That is, in the last class we have discussed the equation, that is 1 mole will produce this calcium carbonate, right? So for that reason we can use it, and 5 mg per liter of alkalinity we are going to add in this raw water. For that reason 5 into 56 divided 100 parts of calcium carbonate, you will get 2.8 mg per liter. So this much of quicklime you have to add in the water sample, but in the question they are given as 88% of calcium oxide. For that reason now we have to find out the quicklime required is equal to 88% of 2.8 CaO. In the question they are mentioning 88% only, so for that reason we have to find out 2.8 into 1 divided by 0.88. so you will get 3.18 mg per liter. Therefore the total quantity of lime required to treat 50 mld of water is equal to 50 into 10 raised to 6 mld, million liter means 10 raised to 6 into 3.18. you will get, by calculating you will get 150 into 10 raised to 6 mg per day. So this we can convert as 159 kg per day. So this is what the total quantity of lime required for the water treatment plant. So for the year means we have to multiply this into 365, you will get the answer. So this is what, how to find out the amount of coagulant required for the water treatment plant for particular quantity of water. So in the next video we can take one more problem based upon the liberation of calcium dioxide, that is carbon dioxide, so that we can see in the next video. To solve this equation, the amount of coagulant means you have to remember the equation, that is when you add aluminum sulfate to the water sample, how the reaction takes place and the equilibrium condition of that particular type of compound. That you have to remember, that you have to understand. Once you got the idea of this equation means it is easy to solve every problem. Okay, thank you.